All right, hi, my name is Brandon Clayton, the Algebra Guy. Today we'll be talking about translating words to algebraic expressions. Very important topic. By the end of this lesson, you will know how to do the following. You'll be taking this sentence right here and knowing how to write an expression. Bianca has dimes and quarters in her purse. The number of dimes is 2 less than 5 times the number of quarters. Let Q represent the number of quarters. Write an expression for the number of dimes. So you'll know how to do that by the end of this lesson. So let's go ahead and jump into it. Question I want to answer today. How are the four operations written as phrases and expressions? So we're going to be translating a mathematical language into English language. How do you write that? And possibly how you go the other way around, to regular language to mathematical language. How do I construct an expression given a word phrase? So now how do I go backwards? What if I'm given a word phrase? How do I go backwards so I can write an expression? Very important topic because this is the heart of algebra. I won't say the heart, but this is a very a big part because in real life, we're translating situations into algebraic expressions and equations because that's the whole point, not just running through numbers, but really trying to make sense of the world around us by identifying patterns and such. So, answering the first question, how are the four operations written as phrases? So let's look at this. Addition. When you see addition, here's a few ways that you're going to know how to write it. So the expression is going to sound like a plus b, but it'll look like this, a plus b. The sum of a and b, there's a key word we talked about before. A increased by b, so you already had a, but you increased it by b. B more than a, the total of a and b. B added to a, you get the idea. All right, subtraction. A minus b. Right here, a minus b. So that's the expression part. This is what it sounds like in the sentence. The difference of a and b, you'll see this often. Just make sure that a goes first. If they're asking for the difference of something, that first one can go first. Pretty easy to remember. A and b, the b subtracted from a. So a was already here, right? And we're subtracting b from it. Keep that in mind. Don't think that because b is written first, it goes first. But b is being subtracted from a. In order to subtract from something, that something has to be there first. So here's the a first. And that's important for subtraction. Order is important. It's not commutative. A decreased by b. So we already had a and it's decreased, which means it's going down. So that's why subtraction. And b less than a. Multiplication. A lot of different ways you're going to see that written, right? So a with this little dot b, a and b next to each other. A parentheses b and parentheses around both of them. As long as you see these two variables or even numbers next together, it means they're being multiplied. Nope. If there was plus, it'd be a plus sign. If it was division, there'd be a division sign of some sort, which we'll talk about, minus it. So anyhow, just you'll see that quite often. So even if it's written 3x, we know that's 3 times x. Division. A divided by b. There we go. A divided by b, a divided by b, and a divided by b. A division, what is it? The quotient of a and b, and you don't see this part as well, so let me see if I can change this so you can see. So there you go. So a divided by b, the quotient of a and b, the ratio of a and b divided into a. So there you go. So we're going to practice a little bit what that looks like so you'll know how to do it. Let me change my screen a little bit and get to our next problem. All right. So we got to translate each word or phrase into an algebraic expression. So let's kind of practice that. The difference of 20 and 4. How would you write that? So don't cheat. Don't look on the right side. How would you write that? The difference of 20 and 4. So with difference is telling us what operation. It's either plus, minus, multiplication, or division. So I'm hoping you're thinking subtraction. So the difference between these two is going to get 20 minus 4. So we're taking each word phrase and put it into an expression. An expression, if you remember, it doesn't have an equal sign. It's not an equation, it's just an expression. So that's one way you could write it. What's another way I could write it? I think that's about it, right? Because 20 minus 4, it's the multiplication and division that gets written in multiple different ways. So what about this one? The quotient of 10x and 3. The quotient of 10x. Quotient is which one? Quotient is going to be talking about our division. Quotient is, that's the answer you get when you divide two numbers. So of 10x, so that's really 10x divided by 3. We can also write that 10x divided by 3. We can do 10x divided by 3 like this. And that's really it. I mean, this one is the same thing as 10x with the slash going that way, divided by it. There should be a 3 right there. So there you go. That's how you're going to go from being a phrase to an actual expression. Translate each word phrase into an algebraic expression. So we just did that one. I'm going to skip that one. And we did that one already. But what about this one? 8 more than y. How would you write that one? 8 more than y. So I have y, but I want 8 more. So you write it like that. So that's how I would think about it. Be careful not writing it the other way. In this case, it doesn't matter why, because we're doing more than. More than is telling us that we're going to be adding something more. And addition is commutative, which means you can move the numbers and it still gives you the same answer. 4 plus 3 is 7, just like 3 plus 4 is 7. But in this case, just the idea that we got 8 more than something, that means that something was there first. So y plus 8. Yes, 8 plus y would also work out here as well. So I could put an equal sign there. I think you get the idea. All right, let's do our next problem for our practice. See if you can write this one yourself before I do it. 7 less than 9t. So 7 less than something. That something was already there, wasn't it? Because I'm going less than. So I'm going to go 9t. 9t. And 7 less than that. 7 less than 9t. Bam. There we go. That's what you're looking for. All right, so what about this one? Can you do this left one first? Let me back up. So that's okay. 5 times the sum of m and n. 5 times the sum of m and n. So we need to take care of this sum. What is this sum? What operation are we talking about? Plus, and we know that 5 times is going to be multiplication. So we got two things going on here. We got 5 times whatever the sum is of m and n. So m plus n. That's the sum of this whole thing. Well, 5 times that whole thing. 5 times this whole thing. Now be careful, because most students will write it this way, but that's actually not correct. This one says 5 times m plus n. But we want to say the sum of m plus n, this whole piece, by putting parentheses around it. And we want 5 times whatever that whole sum was, not just 5 times m. So that's how this one's going to look. The sum of 5 times m and n. So the sum of 5 times, oh my, how am I writing that? The sum of 5 times m and 5 times n. The sum of 5 times m and n. So there's a sum of 5 times m and n. All right, moving on. And here's a word problem. We're going to change it to an expression. The height of a rectangular window is 6 inches less than the width. So I like to draw pictures for this. Let's see if I can get my tools to draw a picture. Yep, there it is. There's a window. Bam. And it says the height of the rectangular window is 6 inches less than the width. So this height right here, we're going to call this up and down part of our height just to make sure it's clear. This height is 6 inches less than the width. So whatever the width is, let's call this the width, W. Let W represent the width. Okay, we did. So this is the width. And we know, let me erase this 8 so no one's confused. So we know that this is the width. This is the width here. Write the expression for the height of the window. So the height is going to be, let me see it again, 6 inches less than the width. So whatever the width is, what are we going to do to it? Well, it's less than 6 inches less, so we're going to take away 6. So now that's my height. My new height is going to be W minus 6, because if that's 10, now my height is 10 minus 6. Be careful to keep that in the right order, because the width was first, right? So whatever the width is, take away 6 more. So that's the way you want to think of that. All right, and this is a problem I told you we started with, and I think this may be our last problem as we're finishing. Bianca, or Blanca, I don't know if I wrote that wrong, has dimes and quarters in her purse. The number of dimes is 2 less than 5 times the number of quarters. Whoa, what? The number of dimes is 2 less than 5 times a quarter. Let Q represent the number of quarters. So Q is going to be our quarters. Write an expression for the number of dimes. So the number of dimes is 2 less than 5 times the number of quarters. So here's my dimes, number of dimes. This whole thing, number of dimes, we're going to let represent D. D is going to be equal to our number of dimes. Number of dimes. And be careful, don't just say dimes, because you're going to be like, what about the dimes? The weight of the dimes, the color of the dimes? No, we want the number of the dimes. So these represent our number of dimes. Dimes is, what can we use to represent is? So dimes is, this is actually going to be an equation, looks like, 2 less than 5 times. So dimes is 2 less, take away 2 from something, less than 5 times what? The number of quarters. And this whole number of quarters piece we'll let it represent with Q. So 5 times Q. So I know my dimes are going to be equal to 5 times the quarters minus 2 more. So this is the expression we're after here. Man, that was a good one, wasn't it? So the number of dimes is 2 less than what? 5 times the number of quarters. So some quarters, but 5 times those quarters. So that's how we're going to finish this one. All right, did we accomplish our goal? Did we talk about how are the 4 operations written as expressions? Yes, we did. We talked about the sum and the quotient and the product and how they were written as expressions. How do I construct an expression given a word phrase? So I just ended with that last word phrase, a couple of those actually, and translated them to expressions. So thanks for tuning in. Again, my name is Brendan Clayton, the Algebra Guy, and I will see you next lesson.